to change pen color. So let me discuss about delta function. And so delta function, how we create. So we are just discussing about two-sided step signal. First of all, we are introducing two-sided step signal. So this is two-sided step signal which present from minus alpha by 2 to plus alpha by 2, and its amplitude we are taking is 1 by alpha. So if you calculate its area under curve, AOC, area under curve, AUC. So this AUC comes out to be 1, right? So this AUC comes out to be 1. If we are trying to tend alpha tends to 0, if alpha tends to 0, then this 1 by alpha tends to infinite. Its amplitude tends to infinite. So if its amplitude means its height tends to infinite. Yeah, right. So if its height tends to infinite, the signal look like. So if alpha tends to 0, so it's present at 0 point and its height goes up to infinite. Okay, so this signal is called as delta signal. This is represented as delta t, right? So basic property of delta function is its area under curve is 1. So the property we have to remember about this delta function is, first property, minus infinity to plus infinity delta t dt, it's 1, right? Okay. Let me stop for a couple of minutes. Okay. I think that recording is not open, but now it is working. Yeah. So its area under curve minus infinity to plus infinity delta t dt is 1. And second property is delta t is equal to infinite at t equal to 0. So otherwise its value is 0 because we are discussing. So first property that we have to remember about delta function. Okay. First about the first property, minus infinity to plus infinity delta t dt is 1. And second property is the definition of delta function is 1 for infinity for t equal to 0. Otherwise its value is 0. Okay, let's discuss more property about delta function. So you have to directly remember this property. No need to derive it. Delta of at plus b, it comes out to be 1 by magnitude of a delta of t plus b by 2. Okay, this is foremost property, important. Okay. Okay. So let's discuss about next property that we are focusing about. Okay. For that, we have to discuss about a function xt is multiplied with delta t. So delta t is present at t equal to 0. So this function is present at t is equal to 0, x of 0 into delta t. Okay. Xt into delta of t minus a. This is okay. We have to write here xt into delta of t minus a. So this is written as xa time delta of t minus a. Okay, this property you have to remember. Next property about area property of delta function. Okay, so we have to discuss about minus infinity to infinity xt time delta t dt. So this is representing as minus infinity to plus infinity. So this delta t present at t equal to 0. So it can easily write as x of 0 time delta t and integration with respect to dt. So this can easily represent an x of 0 minus infinity to infinity delta t dt. So we can easily represent at x of 0, right? So next question, let me discuss about through some question, some property. Let's take one question, minus infinity to plus infinity. Let's say t square plus 1 multiplied by delta of 2t minus 6. First question. So first question we are discussing. So we are writing minus, okay, minus infinity plus infinity. So first we are writing this function t2 square. So if we are writing, if we take 2 common, so it's represent 2t minus 3. Okay, we have already discussed about property del of at is 1 by mod a. So del of at plus b is represented as 1 by mod a delta of t plus p by a. So if we wanted to write this signal minus infinity to infinity, okay, t square plus 1, okay, and delta of 2t, it's represented 1 by 2 del of at 1 by 2 delta of t minus 3, okay, right? So if we writing about that 1 by 2 minus infinity to infinity t square plus 1 delta of t minus 3, okay, so this signal is present at t equal to 3. So t equal to 3 delta t minus 3, we are trying to draw a signal. So this is delta t function, and delta t minus 3 is we are shifting it towards right. Okay, if we are shifting towards right, though this signal is present at 3. So we have to select value of this function at t equal to 3. So value of this function at t is equal to 3 is 10. So this is simply 1 by 2 into 10 minus infinity to infinity delta t minus 3. So this comes out to be 5. Okay, right. Okay, let's discuss some more property of delta function. Let's discuss some question through question. Minus 2 to 4 delta of t minus 1, okay, into t square dt. Okay, so if you think about this integration limit, this limit is from 2 to 4. Yeah, and let's say this integration limit is from 2 to 4, and our delta function is present at t equal to 1. So this integration is not defined. So uh, can't, because this delta function is present at t equal to 1 only, and this limits vary from 2 to 4. So this integration can't define. Okay, can't define, right? Let's discuss some one more question. So let's say t equal to 2, 2t equal to 4. Again we are taking delta t minus 1 into d into stack. Here delta t minus 1 into t square plus 1 dt. So we are discussing about that this signal is present from 2 to 4. but this delta function is present from 1. So otherwise its value is 0. So its value is already 0, and 0 multiplied with any function within bounded limit, its answer is 0, right? Yeah. Okay. Let's discuss about another function t equal to 1 to t equal to 2. Delta t minus 1 t square plus 1 dt. Okay. This signal we have to write. So this signal integration is present from 1 to 2. But this delta function is also present from 1. At 1, its amplitude is infinite. But this integration is from 1 plus 2 up to 2, not exact to 1 value. So we can't define this integration. So it comes out to be can't define. Right? Right. Okay. Okay. Let me solve one numerical. Okay. Minus 10 to 3 5t plus 6 delta t plus 5 plus 90 square delta t plus 3 and integration with respect to dt. So this function is present at t equal to minus 5. So we have to just put t equal to minus 5, and minus 5 is within the limit. Yeah, right. And this t is equal to minus 3 also within the limit. Yeah, right. Function is defined. So we have to just put minus 5 plus 6 plus 9 plus 3 counts. So this is okay. So till now we are closing this session. So next session we are discussing about different property of ramp signal. After ramp signal, we are discussing about triangular signal, and also we are creation of some signal, periodicity, and other energy and power signal we are also discussing. So till now close. Okay.